Hello everybody, welcome back to another Gregorius Maths video. Today I'll be doing number theory again. Namely, I'll be proving the Euler's product formula for the zeta function, which involves the primes and everything. So yeah, okay. Big shout out to Black Pen Red Pen. He commented on one of my videos. You better subscribe to him. I've got 6 subscribers. He's got 437k, I think. So for him to comment on one of my videos was very nice of him. So yeah, you better subscribe. Anyway, I'll be proving this theorem which Euler first came up with. So I don't know whether to write theorem or definition. I'll write theorem. Right, okay. So, zeta of S, the zeta function, I've introduced this before, equals the product over all the primes. So I'll write it like this, P equals primes, okay, of 1 over 1 minus P to the negative S. And this converges, a little side note for you guys, this converges for the real part of S greater than 1. That's just a little side note. Okay, so what's the proof? In fact, yeah, okay. I'm not going to write this as part of the theorem, even though it's true. Just know that, okay? The zeta function has a pole at S equals 1, even with the analytic continuation. So what's the proof of this? So let's write out zeta. Zeta of S equals 1 plus 1 over 2 to the power of S plus 1 over 3 to the power of S plus 1 over 4 to the power of S plus 1 over 5 to the power of S plus... Okay? And now, I think it would be interesting if we just multiplied both sides by 1 over 2 to the power of S. So, 1 over 2 to the power of S times zeta of S equals, what's 1 times 1 over 2 to the power of S? Just 1 over 2 to the power of S, plus 2 times 2 is 4, 1 over 4 to the power of S, plus 1 over 6 to the power of S, plus, that's not a 5, that's an S. That's not a 5, okay, that's an S. Plus 1 over 8 to the power of S, plus 1 over 10 to the power of S, plus, and so on and so forth. Which means that when we subtract these two, we get 1 minus 1 over 2 to the S times zeta of S. Okay? If you distribute this in, you'll get zeta of S minus this, okay? That's just a nicer way to write it. Equals, we see that the 1 stays there, plus this and that go away. But the 1 over 3 to the power of S stays, plus this and that go away, but the 1 over 5 stays. Plus this and that would go away, and the 1 over 7 stays. And I hope you can see where this is going. These are all the reciprocals of all the odd powers of S, I guess. Or the sum. Okay. But now, what happens if we multiply again? So we're going to try and exploit a sieving property of the Riemann zeta function, which you'll see in a second. So 1 over 3 to the S times 1 minus 1 over 2 to the S times zeta of S equals, this becomes just a 1 over 3 to the S plus 1 over 9 to the S plus 1 over 15 to not 5, 15 to the power of s plus 1 over 21 to the power of s plus... And now, we can see that when we subtract these two, we get 1 minus 1 over 3 to the s. 1 minus 1 over 2 to the s times zeta of s equals. This 1 stays there. This and that will cancel. But the 1 over 5 stays there. The 1 over 7, it stays there. The 1 over 9, that and that would have cancelled. 1 over... but the 11 doesn't cancel out. Plus... but we're avoiding all of these. Okay? We're not discriminating, just maths. Okay. So now, what we're starting to see is that if, and this is what I was talking about exploiting the sieving property, if we carry this on infinitely, we can observe something. So, let's observe that. I'm going to bring this to the front so it's easier for me to write, because I can't write right to left, unlike the Arabic. Zeta of s times 1 minus 1 over 2 to the s times 1 minus 1 over 3 to the s times 1 minus 1 over 5 to the s times equals, and all that will be left over is just this 1. So now dividing both sides by this little chunk here leaves us with zeta of s equals 1 over 1 minus 1 over 2 to the s times 1 minus 1 over 3 to the s times 1 minus 1 over 5 to the s times 1 minus 1 over 7 to the s, and so on and so forth, which equals the product for all of the p equal to the primes of 1 over 1 minus p to the negative s. And I say QED like 90% of the time, so we'll draw the box. Okay, that's good. And that's also it. So, hopefully this shows why these two are equivalent. And I'll see you guys in my next video. Goodbye.